in two variables. So this is very similar to what we did with the systems of linear equations. And I originally had one of the different equations, but I decided to do one where we include a standard form here as well. So we'll get to that one in a little bit. But let's start with the two systems that we have, right? So we have both of these inequalities are in y equals mx plus b, or slope intercept form. So in this case, we're able to identify here the slope, which is -3/1, and then the y-intercept in this case, right, is +1. So for the first one, I want to first plot the fact that we have the y-intercept at 1, right? So here we will start at +1, and then we have a slope of negative. So we're going to have in this case, fall over run. So in this case, we'll fall down 3. So 1, 2, 3, run 1. So that'll be our point there. And if we notice here, I'm going to actually do another point. I'm going to go down 3, 1, 2, 3, 1 to the right. So I have now 3 points, right? So at this point, if we notice, here we have a less than or equal to. So in this case, that means that it'll be a solid line, right? So when we connect these, we should have a solid line going through these points. So I'm going to extend this, and it'll be something like this right here, right? So this goes this way and this way. And again, now we have to test a point for this first one. So the first inequality we're going to test 0, 0, and we get 0 is less than or equal to -3 times 0 plus 1. Again, I'm taking that from this equation, this inequality right there, right? And then we get 0 is less than or equal to, this is 0, so 1. So is 0 less than or equal to 1? The answer is yes, it is, right? So again, 0, 0 is right here. So we could say that yes, in this case, it is a possible solution. So we're going to shade on the side of the point that we tested. In this case, it would be on the left-hand side of this inequality here. Okay? Actually, let me keep the same color so we can kind of see the overlap. So in this case, I'm going to use blue instead. So this is the blue. So we shade on the left-hand side for this one. Okay? Now we're going to go to the second equation. Let me just turn this off. I don't want nobody bothering me. So the next one now, the slope here, right, for this one is 5/2. So the slope for the second equation was 5/2. That's positive, so rise over run. And then the y-intercept for this one is at -4, right? So the y-intercept is at -4, right? So in this case, I'm going to make it red. And you know what? Let me erase this point right there. So I tested that blue one. Now I'm going to make this in red, so this was still shaded in. All right, so now I'm going to move forward to this one. So again, the slope is the y-intercept is -4, so I'll start at -4. And then my slope is 5/2, so go up 5. 1, 2, 3, 4, 5. Run 2, 1, 2. That's right here. Do it again. 1, 2, 3, 4, 5. Up. 2 to the right. Run 2. Oops. 1, 2, 3, 4, 5. 1, 2. Right here. Okay. And in this case, again, this one was greater than or equal to, so it's also a solid line. And we could connect them now. Be careful. Extend the line. And now again, we're going to test the point. In this case, again, 0, 0 is on this side, right? That's 0, 0 right there. I'm going to make it black. 0, 0 is right here, right? So So we're going to test that point and test 0, 0. Test it for the next one. So y is greater than or equal to 5 over 2 times 0 minus 4. So we get 0 is greater than or equal to negative 4. That is true, right? So therefore, we will shade on the side of the 0, 0. So the left-hand side. The left-hand side of this red one. And now we could determine that the solutions are where the overlap exists. And again, the blue line, this was shaded on the left-hand side, right? But now we could see that this whole entire region right here, right, this region overlaps, right? So that means that those are the solutions that makes both of these inequalities true. And now we could do something similar with the second one, but we got to just keep in mind that the first equation is in standard form. So for this one, we're going to have to find the x and y intercept. So we will write 2x minus 4y is less than 24. Actually, you know what? I'm going to graph the bottom one first, just because it's already set up in slope-intercept form, right? So that's our slope, negative 2 over 1, and our, our y-intercept is at negative 1 in this case, right? So again, we start at negative 1. So negative 1 is right here. We have a slope of negative 2 over 1, so this one's fall over run, because you have a negative slope here, right? So it's fall over run, so go down 1, 2, and then run 1 to the right. Do it again, down 1, 2, 1 to the right, down 1, 2, 1 to the right. So once we have a few points, again, we just connect these, extend the line. And again, we want to test the point here, right? So 0, 0 now is on this right-hand side. So we're going to test 0, 0, and we get 0 is, it was greater than. So greater than or equal to negative 2 times 0 minus 1, because 0 is greater than, this is 0, it's negative 1. Is 0 greater than or equal to negative 1? The answer is yes, it's true, right? It is true, so therefore, we shade on the side of the testing point. In this case, 0, 0, right? So we shade on the right-hand side, because that means that all these solutions that I'm shading on the right-hand side, all these possible combinations here will make this inequality here true. But now we would have to take this one, right? So I'm going to make a little line. Now we have 2x minus 4y is less than 24. And again, for this one, we want to find the y-intercept. We said x is equal to 0, and the x-intercept, we set y equals to 0, right? So in this case, if x is equal to 0, we would do 2 times 0 minus 4y is less than 24. We get negative 4y is less than 24. Divide by negative 4 to both sides. Y is, in this case, we divide by negative, the sign would change. It'll be y is greater than negative 6. Now for the second one, we would do substitute y for 0. So we get 2x minus 4 times 0 is less than 24. This cancels out. We get x is less than 24 divided by 2. In this case, x is less than 12, right? So now we have our x and y intercepts. So our y is a negative 6. X is 12, so this will actually be 7, 8, 9, 10, 11, 12. So actually, we're going to have to play it by ear. That'll be like somewhere over here, which is fine. All right, we're going to extend it something like this. And then we will have to test the point still, right? So we're gonna test again 0, 0, 0, 0 is still up here, 0, 0. So we're gonna test the point, and we get 2 times 0 minus 4 times 0 is less than 24, 0, 0. So 0 is less than 24 is true. So it means we have to shade up in this case, right? The side of where the 0, 0 is at. So since 0, 0 was true, that means that all the points on the side of where 0, 0 is at, that region, is also going to be a solution. And again, now we're looking for what's the region that overlaps both of the colors, and that would be this whole entire region right here, right? So this region right here, all of these, the region overlaps. So that means that these are all the solutions.